This question is about some group 7 compounds. Solid sodium chloride reacts with concentrated sulfuric acid. So this is memory work. You need to remember that chloride ions are not a powerful enough reducing agent to reduce sulfuric acid, and so all they do is react in an acid-base reaction. The chloride ions accept a proton to make steamy white fumes of HCl, and we're left with sodium hydrogen sulfate. So the H2SO4 has donated a proton, the Cl- has accepted it, the two other ions have then combined, and so the role of the sulfuric acid as a proton donor or as an acid. Fumes of sulfur dioxide are formed when sodium bromide reacts with concentrated sulfuric acid. So we can see that the sulfuric acid is being reduced now to sulfur dioxide. Give an equation for this reaction. So you may have remembered it or you may work it out. Because it's a redox reaction now, we could think of what is happening in the two half equations. So H2SO4 is becoming SO2. The sulfurs are balanced. I'm going to add 2 waters to balance the oxygens, and then 2 H pluses to balance the hydrogens, and then 2 electrons to balance the charge. And the bromide ions are being oxidized to bromine, and that is by losing 2 electrons. So if I were to combine this, I would get H2SO4 plus 2 H pluses plus 2 Br minuses, or you could have written that as 2 HBrs, make sulfur dioxide, 2 waters, and a bromine. Now there are other versions of that equation that you can use, including the sodiums, but I think this is the easiest, the simplest version to apply. What other observations other than the fumes of sulfur dioxide would you see? And the key is that you're going to see the bromine, which is orange-brown fumes of bromine. And the role this time of the sulfuric acid is to oxidize the bromine, so it is an oxidizing agent. It itself is being reduced. It is an oxidizing agent. Chlorine reacts with hot aqueous sodium hydroxide, as shown in the equation. Give the oxidation state of the chlorine. So chlorine is -1 unless it's combined with oxygen. So in our bottom compound, it's just -1. The sodium is +1, chlorine is -1. In the top one, sodium is +1 and each oxygen is -2. So we've got 1 take away 6 is -5. So we need to add +5 to get back to the neutral charge. So the chlorine in sodium chlorate is a 5. State in terms of redox, what is happening to chlorine? Well, it was 0 and it's going to +5 and -1. So it's going up and down. It is both oxidized and reduced. You would be allowed to say it undergoes disproportionation, or it both gains and loses electrons. Solution Y contains 2 negative ions. Somebody adds silver nitrate. Okay, that tests for chloride, bromide, or iodide, depending on the colour. Then they add acid. That removes carbonates or fizzes with carbonates. And then they add ammonia, concentrated ammonia, that dissolves AgCl or AgBr, but not AgI. And their observations are recorded. So we get a cream precipitate, which kind of indicates it might be AgBr, containing D and E, compound D and compound E. So there might be a second precipitate inside there. When we add acid, we're still getting a cream precipitate of AgBr and bubbles of gas F because the carbonates have reacted with the acid to give off CO2. And then when we add the ammonia, we're getting a colourless solution, and that is because the silver bromide is dissolving and making the ammoniacal silver complex. So give the formulas of D. So that would be AgBr. E is the one thing that we haven't really figured out. It was something that when we added the nitric acid reacted, the silver would have reacted initially with the carbonate ions, and because silver's a 1+ and carbonate is a 2-, then E must be silver carbonate. This is why we normally add acid before adding silver nitrate, to remove these possible false positive precipitates of silver carbonate. Formula of F is carbon dioxide gas. We worked that one out. Equation to form E, so we're trying to form silver carbonate precipitate, and that would form from silver ions and carbonate ions, and we can see that we've got 2 silver ions in there to balance the charge of the carbonate ion. And then the conversion of D, which is our AgBr, into G, which is our complex ion. And we're doing that by adding ammonia. We can see that we're going to need 2 ammonias. Now the charges have to balance, so what's balancing out this 1+ is a Br1-.